The topic is triple integrals in spherical coordinate. So let's do this example. Use spherical coordinates to find the volume that lies above the cone z equals square root of x squared plus y squared, and below the sphere x squared plus y squared plus z squared equal 9. So the sphere would be rho equal 3. So here's the sphere. The distance from the origin will be 3, 3, 3. And then the cone z equals square root of x squared plus y squared will be that. Right? So we need to find the volume that lies above the cone and below the sphere. So we need to know the phi again. So we need to know the angle phi. Here's another way of doing it. Instead of converting the equation z equals square root of x squared plus y squared to spherical, you could look at the contour when x is equal 0. So in other words, if x is equal, the contour will be square root of x squared plus y squared equals some constant. So, well, actually, no, I want to look at the intersection of the cone with the zy plane. So if I let x equal 0, I know my z is equal square root x squared is 0 squared plus y squared. This tells me z is equal square root of y squared, which is z equal absolute value of y, which means z equal minus plus y. Right? If we graph it, well, and I know, here we go. This is going to be z equal y. It's going to be z equal negative y, right? Or z equal absolute value of y will be that. That's the graph of z equal absolute value of y. It's a V shape, and of course, because it's z equal y, I know if y is equal 1, then z has to be equal 1, right? Y equals z. So tangent of, let's use this angle. Let's call this theta. It's not the same theta. Let's call it beta so we don't confuse it. So tangent of that beta will be 1 over 1, which means that angle is pi over 4. But since this is pi over 4, then the phi has to be also pi over 4, right? Because the whole thing is pi over 2. So we know phi is pi over 4. So I know I'm looking for my region is going, or my solid going from here to here. So I'm going from phi equal, remember phi goes from here. I'm going from phi equal 0 to phi equal pi over 4. So I know my phi has to be between 0 and pi over 4. I know my radius has to go from here to here. So, not the rho is going to go from 0 to the sphere, which is 3. What else? And I know my theta has to do the whole revolution. So theta is going to go from 0 to 2 pi. Alright, so we're ready to calculate volume of E. Volume of E will be equal, my alpha go from 0 to 2 pi. I'll start with that, and then I start with phi. Phi goes from 0 to pi over 4. And rho goes from 0 to 3. And then I write rho square sine phi d rho d phi d theta. So I'll do the inner integral first. This will be equal rho cube over 3 between 0 and 3, and then I want my double integral to go from 0 to 2 pi, 0 to pi over 4. And don't forget sine phi is a constant, I'm not going to touch it. And then d phi d theta. If I plug at 3, I get 27 over 3, which is 9, minus 0. So 9 sine phi d theta. Phi goes from 0 to pi over 4. Theta go from 0 to 2 pi. Right, now this is going to be equal to, theta goes from 0 to 2 pi. Integral of sine phi is negative cosine phi between 0 and pi over 4 d theta. Plug in pi over 4, so minus cosine of pi over 4, minus minus is plus, cosine of 0, integral from 0 to 2 pi d theta. Cosine of pi over 4 is 1 over square root of 2. Cosine of 0 is 1. And integral of d theta is theta, and the constant I'm not touching. So theta between 0 and 2 pi. Now plug in the 2 pi. I get 2 pi, 1 minus 1 over square root of 2 minus 0. Let's rewrite this a little bit. So that would be square root of 2 minus 1 over square root of 2 times 2 pi. And that's it for this example.